type of regression algorithm. Let's discuss the next type of regression algorithm, which is ridge regression. Ridge regression is a technique for analyzing multiple regression data that suffers from multicollinearity. Multicollinearity or collinearity is the existence of near-linear relationships among the independent variables. Ridge regression reduces standard errors by adding a degree of bias to the regression estimates. The main idea is to find a new line that has some bias with respect to the training data. In return for that small amount of bias, a significant drop in variance is achieved. So the equation here is minimizing objective equals LS OBJ plus lambda times the set of sum of the square of coefficients. Where LS OBJ refers to last square's objective, lambda controls the strength of the penalty term. Let's move on to lasso regression. Lasso regression L1 is similar to ridge regression, but it also performs feature selection. It will set the coefficient value for features that do not help in decision-making, very low, potentially 0. It is a type of linear regression that uses shrinkage. Shrinkage is where data values are shrunk toward a central point, like the mean. The lasso procedure encourages simple, sparse models. So the equation here is minimization objective LS OBJ plus lambda times the set of the sum of absolute coefficient values. Lasso regression tends to exclude variables that are not required from the equation, whereas ridge tends to do better when all variables are present. This particular type of regression is well suited for models showing high levels of multicollinearity, or when you want to automate certain parts of model selection, like variable selection, parameter elimination. Finally, let's discuss elastic net regression. Elastic net regression combines the strength of lasso and ridge regression. Elastic net first emerged as a result of critique on lasso, whose variable selection can be too dependent on data and thus unstable. The solution is to combine the penalties of ridge regression and lasso to get the best of both worlds. It is the sum of squared residuals. If you are not sure whether to use ridge or lasso, use elastic net regression. Demo Big Mart. Problem statement. The data scientists at Big Mart have collected sales data for 1,559 products across 10 stores in different cities. Also, certain attributes of each product and store have been defined. The aim is to build a predictive model and find out the sales of each product at a particular store. Using this model, Big Mart will try to understand the properties of products and stores which play a key role in increasing sales. Let's now try and understand what could affect the target variable sales. 1. The time of the week, that is, weekends as they are usually busier. 2. Higher sales according to the time of the day, that is, morning and late evenings. 3. Higher sales during the end of the year. 4. Store size and location. 5. Items with more shelf space sell more. Let us import the required libraries and load the dataset in Pandas data frame. Importing NumPy. Import NumPy as NP. Importing Pandas data frame. Import Pandas as PD. Importing sklearn libraries for label encoder and linear regression. From sklearn.preprocessing import label encoder. From sklearn.linear_model import linear regression. Importing metrics libraries for evaluating the model. From sklearn.metrics import R2_ mean_squared_error. From map import sqrt. Use the head parenthesis method to return the top 10 rows of the data frame. We also get an idea of the columns present. Note that the item underscore outlet underscore sales is the target variable. Train.shape. There are 8,523 rows and 12 columns. Checking for null values. The column item underscore weight has 1,463 missing values, and outlet underscore size has around 2,410. Printing the unique values in the item underscore fat underscore content column, we notice there are only two unique types of fat that are low fat and regular. Printing the unique values in the outlet underscore establishment underscore year column, we can observe that date ranges from 1985 to 2009. We can also calculate the outlet age. Let us also print the unique values in outlet underscore size. Notice there are also missing values in this column. Using the describe parenthesis function, we get the descriptive statistics of the data frame. Here are some observations. Item underscore visibility has a min value of 0. This makes no practical sense because when a product is being sold in a store, the visibility cannot be 0. Outlet underscore establishment underscore years vary from 1985 to 2009. The values might not be apt in this, from which is why we earlier converted the values to how old the particular store is. It should have a better impact on sales. The lower count of item underscore weight and item underscore outlet underscore sales confirms the findings from the missing value check. Let's explore further using the frequency of different categories in each nominal variable. Printing the count value of columns items underscore fat underscore content. Printing the count value of columns item underscore fat underscore content and outlet underscore size. Printing the count value of columns item underscore fat underscore content and outlet underscore size, we observe low fat is most abundant. Medium and small scale outlets are the highest. We will use the mode function to find out the most common value that appears in outlet underscore size. The output shows that medium is the most commonly occurring value. We found two variables with missing values, item underscore weight and outlet underscore size. Replacing missing values in outlet underscore size with the value medium. Replacing missing values in item underscore weight with the mean weight. Plotting histogram reveals the distribution of item underscore visibility column. Detecting outliers. An outlier is a data point that lies outside the overall pattern in a distribution. A commonly used rule says that a data point is an outlier if it is more than 1.5 IQR above the third quartile or below the first quartile. Using the same, we remove the outliers and output the resulting data in filt underscore train variable. Calculating the first quintile for item underscore visibility. Calculating the second quintile.